we're going to be learning a lot of information about lines. So first we need to know what is a line. So we've all seen a line drawn. We know it's a straight line with arrows usually on the end to say this is going forever. But really this line is made up of a bunch of small points. If we could draw infinitely many points, we'd have a whole bunch of points, so many packed together that it creates this line. You'll notice that we can only follow this same pattern though. I can't have a point out here, it's not on the line. So this is really infinitely many points. We have an infinite amount of information from it. But when we go to draw a line, we don't want to draw an infinite amount of points. You really only need 2 anywhere on the line. I could have two points close together and I can still connect them. If I connect them with a straight line, it's going to follow the same pattern. If I had 2 points far apart, it would still connect in the straight pattern. So for any line, you only need 2 points, and that would give you enough information. So this is a key thing in mathematics. To draw any line, you only need 2 points, even though there's really an infinite amount of them. So the reason we want to learn about lines is because we can actually describe real-world situations with equations and lines. One real-world situation is temperature. Many countries measure their temperature in Celsius. You'll see the C for Celsius, whereas in the United States of America, we measure our temperature in Fahrenheit. So sometimes you might need to convert that, because if they say it's 30 degrees Celsius outside, you might think, oh, that's really cold, I need a jacket. But 30 degrees Celsius is actually 86 degrees Fahrenheit. So we can describe this situation using this equation. Now this isn't currently in function notation, but we need to get used to that function notation because we use it a lot. So instead of f, we're going to say f of x. That function notation, often we'll see that as the letter y as well. And instead of c, we're going to use x, just so we can keep track of this function notation. So how do we get a picture from this equation? How do we take this and put it as a line on the coordinate plane? To do that, we need to create a table. To create a table, we actually get to pick the x values. We are given some temperature in Celsius, and we want to figure out, well, what is that in Fahrenheit? So let's start with a negative temperature. Let's say it's negative 10 degrees outside. Not many places get that cold in Fahrenheit, but what does negative 10 degrees in Celsius mean? So to do that, we're going to plug that number we picked into the equation. We want to find f of negative 10. So we have the fraction 9/5. We're replacing the letter x with the negative 10, so times negative 10 plus 32. Well, I don't know what 9/5 times 10 is, times negative 10, so let's plug it into a calculator. We're going to use the Desmos online calculator quite often. It will graph things, but it'll also just calculate things for you. So you can type in a fraction, or you can use these buttons down here. I could have typed in 9 divided by 5, because the fraction bar is really just division. Then we have to click to the right. We don't want to remain on the bottom of the fraction, so we just click to the right and hit times negative 10. There's no separate negative symbol, so we're going to use the subtraction symbol for the negative. So times negative 10 plus 32. That gives us 14 degrees. So still pretty cold. 14 degrees in Fahrenheit, still pretty cold. Both of these are degrees. So that point on the table could also be written as a coordinate, and we can graph it on the coordinate plane. Now you'll notice we're going 1, 2, 3, 4, 5, negative 10's all the way over here, and 14's off the graph. We're going to change these values. Instead of 1, we're going to say this is 10. Sometimes you have to change your units to make this come out nicely. So each of these is going to be -10, -20, 10, 20. So we could plot the point -10, 14 by going left to the -10. We have to kind of approximate 14 is going to be in between 10 and 20. So 10, 14, -10, 14 goes right there. So let's try another one. Let's say what happens when you're 0 degrees Celsius. So again, using that function notation, we're finding f of 0. We're going to plug in 0. And this time, I don't need a calculator because any number times 0 is still 0. When that multiplies out to be 0, then we do 0 plus 32, and that's still 32. 0 is one of those special numbers that can be nice to work with. So 0, 32. When it's 0 degrees Celsius, it's 32 degrees Fahrenheit. So 0 means we don't go anywhere left or right, but then we're going to move up to 32. Remember, each of these are actually going by 10 now. 10, 20, 30, 40. So that's enough to draw a line. We have 2 points. Any 2 points can be used to create a straight line. So if we connect these dots, then we've created a line that describes every situation we might want to know about the temperature in Celsius compared to the temperature in Fahrenheit. Just looking at the graph now of this line, we could say, well, if it's 30 degrees Celsius, what is that about in Fahrenheit? So we would follow the 30 up to the line. We're about here, so 30 degrees Celsius is about 78 degrees Fahrenheit. Now some of this might be off because I'm drawing it by hand. So we can also use the Desmos calculator to check some of our work and actually look at the graph on Desmos. If we type in the equation, f of x equals 9 divided by 5, we have to click to the right to get it out from under the fraction, x plus 32. My graph is kind of weird. I'm going to drag it around so you can see it a little bit better. This one's going by 5s instead of by 10s. We could zoom out and try and get it to 10s like this so it matches our graph a little bit better. And we'll see at 30 degrees, we're actually up to 86. So our graph by hand was not as accurate as a graph by a computer. But if you did need to know an exact temperature, you could keep plugging it in. We can predict any temperature from Celsius to its temperature in Fahrenheit. So when we have equations of lines, sometimes we'll need the actual equation. We started with the equation. Sometimes we might need to make a table. And this table only has 2 points. Usually tables have 4 or 5. But we stopped at 2 because that's all we needed to draw a line. And sometimes we'll need the picture of the line, which we call the graph.